Okay, so we're going to learn our first step of factoring today. We'll talk about what that is in just a minute, but before we do, we want to review something we've already done, which is multiplying a polynomial, which remember means many terms, by a monomial. So what do you remember about this? I want you to try to simplify these two problems, then turn the video back on and check your work. So this was simply distributive property. We took this monomial outside the parentheses, we multiplied it by everything inside the parentheses. Remember, when we're multiplying power with the same base, we add the exponents. Here we had more than one variable, we did the same thing. So this is multiplying, and this is using the distributive property. What we're going to do today is we're going to factor. We're going to basically undo this. We're going to start with this answer, and we're going to get the question. We're playing Jeopardy. Going to start with the answer. What was the question? Okay? Let's see how it works. So, factor means to write as a product. Anytime you see that word, that means you're going to be given a polynomial, which will be the sum or difference of terms, and you have to write it as a product. This particular type of factoring is going to be undoing the distributive property. Sometimes I call it the antidistributive property. So what we want to do, we want to find the GCF, the greatest common factor of these two terms. What goes into both of these terms? What's the GCF of 3 and 12? What's the biggest number that goes into 3 and 12? 3, right? And then you look at x squared and x, and you want to see what's the highest power of x that will divide both of these. Well, you have to use the smallest exponent. So make a note that for common variables, use the smallest exponent. And what we're going to do is we're going to take this polynomial, 3x squared plus 12x, and we're going to divide it by that GCF, or that greatest common monomial. Sometimes you'll see it called the GCM, by 3x. And we're going to do this little upside down ladder division. So we're going to say 3 into 3 goes one time. How many times does x go into x squared? Now, I'm going to go over here to the side and show this. You won't have to show this every time, but when you divide with the same base, you subtract the exponent, so x squared over x is just x. So 3x into 3x squared, we're left with x, plus 3 into 12 is 4, and x into x, those cancel, right? If I have x over x, those cancel, those become 1. So I look at this, do I have anything common to x and 4? No, so my answer is 3x, that's what I had out here, times what I get down here, x plus 4. If you were to do the distributive property to 3x times x plus 4, 3x times x is 3x squared, 3x times 4 is 12x. What if I have 21a cubed minus 14a squared? We want to find that GCF. What's the GCF between 21 and 14? The biggest number that divides 21 and 14 is 7. Then you look at your common variables. A is common to both of these. You use the smallest exponent, so we're going to use a squared. So we're going to take that 7a squared, and we're going to divide it into 21a cubed minus 14a squared. So 7a squared into 21a cubed, 7 into 21 is 3. A cubed divided by a squared is just a. If you need to see that, a cubed divided by a squared, when you're dividing, you subtract the exponents, you get a. Then 7 into 14, that's going to be a minus 2 because of that negative there. a squared divided by a squared, that cancels. So I end up with 7a squared times 3a minus 2. You can always check factoring. If you were to re-multiply this, you should get what you started with. Next, I have the polynomial 8p minus 4q plus 12. I look at my numbers, 8, 4, and 12. What is the GCF of 8, 4, and 12? What's the biggest number that goes into all three of those? That's 4. Then I look and I don't have any common variables. This p is not common to all three terms. This q is not common to all three terms. So since there's not anything common, any variable common to all three terms, 4 is my GCF. So I'm going to divide the whole polynomial by 4. 4 goes into 8p, 2p times. 4 goes into minus 4q, minus q times. Those 4s would cancel, and you'd be left with q. And then 4 goes into 12 3 times. So I end up with 4 times 2p minus q plus 3. Next we have the polynomial 18x cubed minus 6x squared plus 24x. I look at my numbers, 18, 6, and 24. What's the biggest number that divides all of those? I believe it's 6. I look at my variables. Is x common to all of them? Yes, so I'm going to use an x. And what's my smallest power of x? My smallest power of x is just x. So I'm going to factor out a 6x. And you factor by dividing when you're factoring using this antidistributive property stuff. 6 into 18 is 3. X cubed divided by x is x squared. Minus, these 6's would cancel. X squared divided by x is x. Then 6 goes into 24 4 times. Those x's would cancel. My final answer is 6x times 3x squared minus x plus 4. Remember that you can check this. If you were to redistribute, you should get what you started with. What if we've got more than one variable? You take it one part at a time. First you look at your numbers, 8 and 12. What's the highest number, the greatest number that is a factor of 8 and 12? That would be 4. Then you look at a. Is a common to both terms? Yes. The smallest power, the smallest exponent is the first, so I'm going to use 4a. Then you look at the b. Is the b common to both? Yes. You use the smallest power, which is just b. To be part of this GCF, it's got to be common to all the terms. It can't just be in one of them. And you always use the smallest power that's common to all. So now I'm factoring out a 4ab. I'm going to divide 4 into 8, goes 2. These two a's would cancel, and b into b squared would leave me with a b. Remember, when you're dividing powers with the same base, you subtract the exponents. 4 into 12, I'm going to have a minus 3. A into a squared is a, and my b's would cancel. So I end up with 4ab times 2b minus 3a. Always check, re-multiply, you should get what you started with.